All right, now we're going to move away from equations into solving inequalities. An inequality is a mathematical sentence that compares quantities. Solving an inequality means finding values for the variable that make the inequality true. The table below gives some examples of the words you might use when describing different inequalities. Words like is less than or is fewer than mean the less than symbol. Words like is greater than, is more than, and exceeds mean the greater than symbol. If you say is less than or equal to, then it would be the less than or equal to sign. Is no more than and at most would also be the less than or equal to sign. Notice the equal bar underneath it. This is going to be very important when we go to graph inequality solutions. Then we have over here is greater than or equal to, is no less than, and is at least. Those actually represent the greater than or equal to bar. Now, I want to point something out. These words right here. It says is no more than, is at most. When you see more and most of us would think greater. But actually, because of the word no more and at most, that actually is the less than symbol. The same thing happens over here with these words. Is no less, is at least. You see the words less and least, you want to think less than. But because it says no less and at least, it's actually the greater than symbol. So be very careful when you go to write word problems. And we'll talk about that when we get to example, I believe it's number 4. Now let's go back up to the purple box. It says, you can solve inequalities by using the addition property of inequality. If you remember back, we had a addition property of equality. It says you can also use the subtraction property of inequality. Well, we had a subtraction property of equality. Those properties said that when you add or subtract a number from both sides of an equation, the equation remains true. Well, the addition property and subtraction property of inequalities basically say the same thing. When you add or subtract the same number from each side of an inequality, the inequality remains true. So it's the same rule. In other words, when we solve inequalities, we do the exact same thing as when we solve equations. So let's take a look at the examples and see how that plays out when we do those. Example number 1 on page 498 says, x plus 3 is greater than 10. If we said that that was an equal sign instead of a greater than symbol, how would we go about solving this problem? Hopefully, you're so used to this by now that you went automatically, well, just subtract 3 from both sides. Positive 3 and negative 3, hey, those are opposites, so they cross off, leaving me with x. 10 minus 3 is 7, and I just bring my sign down. X is greater than 7. And you would be correct. That's exactly how we're going to solve this one-step inequality. But it can't be that simple, can it? No, it can't. When you solve an inequality, you're not actually getting a single answer. You're actually getting a set of answers. X is not 7. X is greater than 7. That means 7 itself is not the solution to this problem. Since 7 plus 3 is equal to 10, 7 plus 3 is not greater than 10. Our answer actually has to be more than 7. It could be 7.01, but it cannot be 7. So that can be a little confusing for some people, but what it really means is that we really need to graph our solution. Now, we graph solutions on a number line. And if you actually look in your book, they're going to have some number lines in there, and they're going to have lots and lots of numbers on their number line. When we graph these by hand, I'm asking you to only give me 3 numbers. I want you to take the solution you came up with, which is 7, and I want you to put it in the center of your number line. I want you to give me one number bigger to the right and one number smaller to the left. This is how we're going to draw our number lines. It's like a small snippet of a number line. It's not the whole big number line. We don't need all those numbers. We need one bigger number to the right and one smaller number to the left, excuse me. Now, we now need to determine, should this be an open circle or a closed circle? And this is how we're going to determine that. Is 7 equal to x? 7 is not equal to x. Because we have the greater than symbol with no bar underneath it, this is going to be an open circle. So, if x is greater, it is an open circle. If x is less, it is an open circle. If x is greater than or equal to, it will be a closed dot. So if you have more ink on your symbol, you need more ink on your dot. Less than or equal to, also a closed dot, because this means equal. So the extra line means equal, and we must include the solution. But since that extra line was not on here, that means it is an open circle. Now, the next thing we need to determine is which direction to draw our arrow. Here it says that x is big. I know that x is big because the mouth of my symbol, and I'm going to draw it bigger, is trying to eat the variable. If this were a crocodile or alligator, he would want to be eating the letter. So since x is greater than 7, that means numbers like 8, 9, 10, 11, 12, the numbers to the right on the number line, are the numbers that are included in my solution set. So my arrow needs to be drawn to the right. So it is an open circle because there's no equal bar, and because x is bigger, the arrow's got to go to the right. Let's take a look at example number 2. On page 499, we see example 2. It says, solve -6 is greater than or equal to n minus 5. We see that the variable is on the right-hand side of the inequality with minus 5. The opposite of subtracting 5 is adding 5. So we will add 5 to both sides of our inequality. -5 and +5 are opposites and cross off. -6 and +5 have different signs, so we know we need to subtract. And we will get 1, and we take the sign of the bigger looking -6. So we get -1. We bring down our n and our sign. So -1 is greater than or equal to n. So again, like on example 1, we need to graph this. We're going to make a small graph. In the center, we're going to put our solution, -1. To the right, we're going to put one number bigger. Well, one number bigger than -1 is 0. Oh, that's right. When we go to the right from negatives, we have to go towards 0. And then on the left, we would put -2 because the bigger a negative looks, the smaller it is. So when we go to the left, we actually count up to the next highest negative. So this is how we put our numbers on a negative number line. Then we got to remember, what was the rule for the dot? If there is an equal bar, then that means n can be equal to -1. That means we need to use a closed dot on our number line. Because remember, and you can look back at example 1 if you need to, if it is got an equal bar, it's a closed dot. If it does not have an equal bar, it's an open circle. Now, we've got to determine, does my sign go to the, or my arrow go to the left or to the right? Well, I look at n, and n is small. So n is small. That means n is smaller than -1. Well, where are the small numbers on the number line? They are to the left. That means my arrow goes to the left. And right now, some of you are going, whoa, 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 Mr. Man, you just did that wrong. I've had teachers in the past tell me that whichever way my sign is pointing, that's the way my arrow should go. So since the sign is pointing to the right, my arrow needs to go to the right. Well, guess what? You were taught something wrong. That's not how we determine the direction of the sign. Notice where the letter is in our solution. The letter is on the right. Every time in the past when you've had this come up, the letter has been on the left-hand side. Now that the letter sometimes appears on the right, you really have to think about whether the letter is small or whether the letter is big. In this case, N is small. The alligator is turning its back on the letter. It's moving away from it. It's small. That means the arrow has got to go to the left. That brings you up to letter problems A and B, but we're going to move on to example 3 before you do that. It says on page 499, solve A plus 1/2 is less than 2. Hopefully you're going, well, that's easy. Just subtract 1/2 from both sides. Positive 1/2 and negative 1/2 crossed off. I'm left with A. I bring down my sign and I get 2 minus 1/2. Oh, how did we do these? Where I'm subtracting a whole number minus a fraction? Oh yeah, I gotta borrow. I take from my 2, leaving a 1, and then I put a fraction here that has the same common denominator as my fraction. I have to put 2 over 2. This fraction has to equal the 1 that I borrowed, and it has to have the same common denominator as the fraction I'm subtracting from it. So I end up with 1 1/2. And remember, because you started with a fraction, you must end with a fraction. So A is equal to 1 1/2. When I go to graph this, I will put my 1 1/2 in the middle. One number bigger to the right is not 2 1/2. I need to number by halves. So it's going to be 2. One number smaller to the left, I'm going to take away that half, and I'm going to have 1. So it's 1, 1 1/2, 2 on my number line. Now, A is less than 1 1/2. Since there is no equal bar, that is going to be an open circle. And again, you can look back at example 1 to see when it's an open circle and when it's a closed circle. But no equal bar means open circle. No equal bar means open circle. And then A is small because the alligator is turning its back on the variable and is running away. So since the small numbers are always to the left, our arrow is going to go to the left. All right. Notice C and D, they have graphs drawn for you. I need you to graph on every letter problem because that is going to be a challenge for some of you. So we're going to practice it on every problem we do.